Hello, Programming 12. So right now our game is looking, not bad. We got a little map, and we would like for some kind of a creature to come crawling out from the side of the screen and make its way across the world and follow the guidance of our nodes. So let's make that happen. We're going to be making a mob. A mob is just the general word for the thing that we're going to be shooting at in the tower defense game. It's what we're defending our tower against, those darn mobs. So they're going to be fairly straightforward. They're going to have coordinates. They're going to have some kind of movement variables, like a VX, VY type of deal. They're going to have hit points, because eventually they'll get shot at and be destroyed. And they'll have a constructor to tell them where to go when they are first created. They'll even have some kind of move method and function, I should say, and show function to make them show up. Okay, so let's make it happen. Let's start with some instance variables. I'll probably say they have an X and a Y. I suppose mobs could be bigger or smaller. So I'll just keep it simple for now. We'll modify this later on. So we'll get the basics down. I think they'll have a VX and a VY, which will represent sort of their speed in those along those axes. And I think I'll leave it at that for now. We'll later on give you the opportunity to build upon the mob class. So let's just get it to show up on the screen and move according to where the nodes are. Okay, so the next step is we'll make a constructor. So a constructor called mob, and it will take in some parameters. We'll probably tell it which way to be and what way to go. VX. And we'll just assign those variables the parameters. So that won't take too long. All right, so the next step is to make them show, and I'll just draw a circle for now. In the future, we'll probably make this a little more interesting, but let's get a show function. This is a behavior function. We'll just fill with, what color am I not using? Blue? Purple? Purple. Let's go with purple. Fill with purple. I don't care what the stroke is, personally. Maybe I'll just give it some stroke weight. I'll just go with whatever the default is. Let's give it a little bit of a thicker stroke. And we'll draw a circle at X and Y. And we'll make it like 40? I don't know. We'll make it some size. Mostly what I want to do is just test my node system at the moment. So these types of things will be adjusted later on. We'll also make an act function. So what's the deal with its action? Well, basically it's going to move in the direction it's facing. So we'll say X equals X plus VX, Y equals Y plus VY. And actually, to be more clear, we'll move in the direction of our velocity is implying. VX, if it's a positive number, we'll change our X coordinate to the right. Negative, we'll change it to the left. For VY, that's going to raise our Y coordinates if we subtract because of the upside on Y-axis. So if it's negative, it goes up. Positive goes down. And, some kind of combination in between. It's very much like a run and rise to predict sort of like what is the direction that we're going. So we'll go with that for now. And then here's the tricky part. We have to check to see if we collide with a node. And we'll have to go through all the nodes in the node network. So our node network is called nodes. This is a network is a fancy word. It's just an array. We need to go through all the nodes in the array. Excuse me. So let's do that. If I need to go through the array, I have to make some kind of while loop, right? So I'll just use I as my counting variable. Well, I is less than. This is probably a good place to, you could type in however many nodes you have. I have 8 nodes, but it's a little amateur just to type in a number. It seems a little bit basic. So we actually can, maybe our nodes in the future will change or something. So I don't want to have to break or rewrite my code. So I'm going to write nodes.length. That'll actually tell me how many nodes there are. And if I change it, it will automatically update this code. So that's a good thing. Maybe this mob will be in a different map in the future. So I will put in the I++, but that's going to happen at the end of our loop. So I want to keep on going along as we're not at the end, going up by 1. And each time what we want to do is we want to take a look and see if we're colliding with a node. So this is straight out of Programming 11. We did a whole collision, several projects with collisions, where we check to see if like two circles are colliding. And basically what we do is we compare the distance between those circles and the sum of their radii. So the radii it's not super important how this works. Well, there's a announcement. But basically what we want to do is we want to compare it to the sum of the radii. In this case, actually, we don't necessarily need it to collide on the edge. We kind of want to wait till those circles overlap. So I'm just going to compare to see if my coordinates are within a certain distance of the node's center. So how do we get the node center? Well, we can use this nodes sub I dot x and nodes sub I dot y. And we can just check the distance between those coordinates and our coordinate. So the dist function will check the distance between 2 points. Here's our node, and here's our mob. And we can ask to say if the distance is less than, whatever number you want to say. Less than 1 that's a very tight distance. Maybe we'll put less than 4, sure, we'll try 4. That's very close. In other words, if the distance to the node is very close, then what we should do is we should copy over the distance that it's telling us. So what I can say is I'll say Vx equals the nodes, this particular node's direction x, and our Vy will equal the node's direction y. Oops, I typed a thing wrong. So basically, if it's close, it's going to copy over that, and that's what's going to make it like when it hits the node to like go up instead. So there we go. So now we need a node. Let's see, what should I do to make we got nodes, sorry, we need a mob. So how should we make a mob? Well, I might just start with a simple mob variable and just make it come to life, maybe, or maybe I'll just like throw it into sort of a setup type thing, where I just make a basic one. So let's go for let's make a mob called Mobby. It reminds me of Dobby from Harry Potter. Mobby is going to be created inside of our initialized variables, I guess. Mobby equals new mob, and we have to tell it where to go. So where do I want it to start? Well, I guess I have to go look at where my lines start in my map. So this is probably the coordinates here of where I want it to start. So let's go back, and then I also want it to be at going in the right direction. So this will be 1, 0. This is the Vx and Vy. So if I have no y, it won't be going up and down, and if I have 1 x, it'll be going over to the right. So I can create that, and then over in my play, animate things, I'll just tell Mobby to go. Where's my animate things? I'll just say Mobby.show and Mobby.act. So let's just see if this Mobby bro shows up and follows the nodes. That would be the ideal situation. So I'm going to go ahead and run it, and let's see Mobby. Mobby, yes, Mobby is on the go. And you can see that it hits the node and it obeys it as this distance gets to a certain value. So it looks like it's going pretty well. And you can adjust that number to make it like a little bit lined up. I see it's not quite lined up. I wonder if we can go even as low as like 1 or something. Looks like it's going through. Okay, fantastic. So we have a Mobby that is coming through. Our next job for the next video is we want the next wave button to generate the mobbies, the mob. And when we press that button, that's what we want to happen. So that'll be sort of our next one. But this is going to be our first checkpoint. Before we get into that, I'd like to see that you have the following things for our first checkpoint. You got your intro screen beginning. I'd like to see like some maybe some text here as well. We got a map with a toolbar type of space allocated. We have a path and we have nodes. And of course, Mobby as well, who's moving throughout your maze in a correct path. Okay, so there you go. That's the checkpoint. And then come back to the next video, and you'll see us creating actually an array list of these. We're going to move beyond the array. We're going to use the array list. I think you'll really like the array list for this type of project. Okay, thank you so much, everybody. Bye.